Hello and what's up to you all awesome and wonderful Mindsetters. It is a lovely Monday. It's time for our Triple M Day, which means Mindsetters Maths Monday right here on Learn Extra. My name is Abram and I'm with Natasha today to learn more and learn extra with you guys. Natasha, how are you?
I'm very well. Nice to see you again, AB. Glad you could join us on a Monday.
You know I love Mondays, eh?
Yes.
Because a lot of people run away from Mondays, even at school. Do you normally get that in class that a lot of people don't attend on
Yeah,
Mondays?
but I mean, Monday, you've got to get your Monday off to a great start. It sets up the rest of the week, hey?
I fully agree with you. If you get your Monday wrong, then the whole week will be messed up. But otherwise, what are we doing today?
Okay, well, grade 10s, we're continuing with functions. Last week, we looked at straight lines and we looked at hyperbole. And this week, we're going to look at the quadratic function, otherwise known as the parabola. And we're also going to look at exponential functions.
Awesome, I like that. And just to help you Mindsetters, we have an application which is called More Maths. When you go to moremaths.org on your cell phone, you'll be able to access the application. It's all about mathematics, and you grade 10s would like you guys to take part on our functions questionnaire or answer the questions that are based on functions. And your code is 2FB5. I'll post all the details on Facebook. As you can see, Natasha is trying to show you what's the application all about. So all you need to do is to go to moremaths.org. That's it. That's where you'll find all the details. Register there and then take part. You can see it has got some cool stuff. Hey, Natasha, you can see some statistics and your levels, where you are with the rest of the people that are in a group. You can join our South African group and see just to challenge yourself, how far do you understand the topic that is there and your ranking in terms of your position compared to other Mindsetters on the group. But otherwise, we also have an awesome giveaway, which is a Casio calculator. All you need to do is to take the test yourself questions. The link will be provided on facebook.com/learnextra. That's where you'll be able to see the link that takes you to a Google form. Fill in that form with the right answers, and anyone that gets most correct answers just before 12 tomorrow, they'll be able to win this awesome Casio calculator. Winner for last week's show will be announced during the course of this show. And the notes are also on facebook.com/learnextra. Follow us on Twitter also @learnextra. Back to you, Natasha.
All right. Okay, guys. Well, so glad you could join us and carrying on with functions this week, as I said. Last week, we looked at your straight lines, we looked at hyperbole, and now we're expanding on that, going to the next level. We're looking at quadratic functions and exponential graphs. All right. So basically, in this lesson, as I said, we're going to look at parabolas and exponential graphs. More specifically, we're also going to find the equation of graphs and look at a bit of graph interpretation. I just want to remind you guys about the challenge question for today. Please attempt this and let's see how many of you get it right, and send us your answers and the rest of it, all your questions. Okay, so we are told that there are two parabolas drawn. G of x is equal to ax squared plus p, and h of x is equal to bx squared plus q. Okay, you are given both those graphs on your system of axes. Part A asks you to find the values of a and p. So in other words, you need to find the defining equation of g of x. And then part B, you ask to find the values of b and q, which is the defining equation of h of x. You're then asked to find the values for which h of x is greater than or equal to g of x. And then finally, for what values of x is g of x increasing. Hopefully you all already able to answer those questions, but if not, you will be able to answer those questions by the end of this lesson. So pay attention, get your notes, your notepad ready, and obviously send us any questions that you might have as I'm going through today's lesson. So a quick summary, guys. Let's start with quadratic functions. The defining equation of a quadratic function, or you will also see this called a parabola or parabole, if we're going to do plurals. The defining equation is y is equal to ax squared plus q. All right? For the value of a, that's being the coefficient of x squared, if a is greater than 0, so we're looking at a positive value of a, the parabola has a minimum turning point at 0 and q. So what is this telling you? It's telling you the graph's going to turn at the y-intercept value of q. It's got a minimum turning point, and a is greater than 0. So commonly we say it's your happy face graph or your smiley face. It has a minimum turning point, minimum problems, happy graph, right? So for a greater than naught, you get a graph with minimum turning points. All right. Now, if we look at for a value of a less than naught, so here we're looking at the parabola having a negative coefficient in front of the x squared. Again, your graph is going to turn on the y-intercept, but this time you're going to have a maximum turning point. So if you're thinking about the shape of the graph, maximum turning point, you've got maximum problem, so you are sad. Okay, so if a is negative, we're going to have a maximum turning point. If a is positive, we're going to have a minimum turning point. All right. Now, if the value of q, all right, if that changes, then you will get a vertical shift of your parabola by q units. Okay, so what that really means is the graph is either going to move upwards by a certain amount of units, or it's going to move down your axis vertically by a certain number of units, and that specific distance being q. So guys, I just want to take a moment to show you what happens when the graph moves along the axis when there is a vertical shift. This also applies to what we did last week with hyperbole, where we also looked at the shifting and the moving if the value of q changes. What does this vertical shift mean? So I want to quickly show you with a parabola what happens for the value of q being greater than naught. Okay, so I'm going to take any graph. Say we have y is equal to x squared. All right, that's just your normal graph sitting on the axis, turning at the point 0, 0. Okay, that's your normal parabola that you're all used to sketching. Now say I had the graph y is equal to x squared plus 2. Okay, so we've added on a value of 2 there to the y-intercept. So what that means is that your graph, your original graph, y is equal to x squared, is going to move up your axis vertically. It's going to move up by 2 units. And literally what that means is that the distance between your graph and the new graph, the distance between all the y values, that vertical distance, is always going to be 2 units. So you literally, the shape, everything else stays exactly the same. The graph just moves up the axis 2 units. So the distance between the original graph and the new graph is going to maintain a distance of 2 units all along there. So whatever the value of q is what the distance between your original graph and the new graph will be. So as I said to you before, this doesn't only apply here in parabola, but as you do your exponential functions, you do hyperbole from last week and so on, it's the same concept. Okay, a vertical shift, if you change the value of q, it's going to imply a vertical shift along the axis, either positive in the positive direction, so it's going to move up, or negatively, it's going to move down or slide down the axis. All right. Now let's remind ourselves about the exponential function. The defining equation is y is equal to a times k to the power of x plus q. All right. Importantly, for an exponential function, you will always have a horizontal asymptote at the value y is equal to q. So y is equal to q is your horizontal asymptote. Okay? The y-intercept is always going to be the y-intercept where the graph cuts the y-axis. All right? That value there, that y-intercept there, is always going to be the value of a plus q. Now, intuitively, that should make sense, because if I let x here equal 0, remember that's your exponent, it doesn't matter what the value of this k is. That whole term raised to the power of 0 will always disappear. Anything to the power of 0 is 0. Is 1. You remember that from your exponents. So 1 times a will just give me a plus q. So therefore my y intercept will always be a plus q. All right, so you can almost straight away just change that k to the power of x. If x is 0, you can change that instinctively to 1, because that value is always going to be 1 when you're looking for the y-intercept. All right? Now, if we're looking at the graph y is equal to a times k to the x plus q, remember, again, once you add the value of q in, it means there's a vertical shift happening, right? This is now going to be a vertical shift either up if q is positive or down if q is negative of the original function y is equal to a times k to the x. So it's either going to move up or down by q units. Importantly, with an exponential graph, the value of a gives you the shape, as it does with the parabola. For a greater than 0, so for a positive value of a, the graph curves upwards. So it's going to do that. Okay, that's for a greater than 0. And then if you're looking at for a less than 0, you're going to get a graph that curves downwards. So it's going to look like that. All right, so importantly, the value of a gives you the shape of the exponential graph. Now, the points in that you need to remember when sketching an exponential graph and then when sketching a parabola, we're going to go through as we go through the lesson. We're going to get into those points. And I think our very first question today is based on sketching an exponential graph. We'll go through the steps of how you guys, or what you guys should do in order to sketch that exponential graph. All right, but before we do that, maybe it's a good point, Abraham, to take a break.
Well, in that case, let's do it, Mindsetters. After the break, remember, you have the challenge question. It's up on facebook.com/learnextra, and the test yourself questions are there on Facebook. Check out the link and then submit your right answers. We'll see you after the break. Welcome back, Mindsetters. Guess what? If you're having your cell phone next to you or your desktop next to you and you have access to the internet, why not go to facebook.com/learnextra and join our group of Mindsetters that are over 76,000. And then let's get the conversations going, help one another on the page, share the page with everyone, and then grow as Team Mindset. As we say, we're working together with you guys, and we don't want any of you to be left behind. Remember, if you have some questions, we're also here for you. So go to facebook.com/learnextra, or on Twitter, follow us at LearnExtra. Back to you, Natasha.
Wow, Abby, I can't believe that. 76,000 likes.
Yeah.
That's brilliant. Well done, Mindsetters. Okay, so hopefully some of that 76,000 of you are paying close attention to your screen right now as we start looking at exponential graphs, and we're going to go through sketching an exponential graph. In this case, we've got one. F of x is equal to 3 times 2 to the power of x plus 2. Let's go through the steps. During the break, I just drew up a rough axis there that we're going to use a little bit later on. All right, so the steps. First thing, let's look at the shape of the graph. So we've got f of x is equal to 3 times 2 to the power of x plus 2. Let's just make sure that is correct. 3 times 2 to the x plus 2. All right. We look at the value of a, guys, the coefficient here of the exponent, and we see that that is greater than 0. So straight away we know it's a positive graph. And what we said before, positive graph is going to curve upwards. It's an increasing function. All right. So that's what my graph is going to look like. I know what the shape is. Okay. Next step. Okay, the order of the steps don't really matter. All that's important is that you get all the points down. So don't worry if at school, you do the intercepts first, you do asymptotes next, you do shape last. As long as you get these steps in there, you will get the right graph. All right, so first we look at the shape, right? We know a is greater than 0, so I'm going to have an upward facing graph. Then I'm going to look at what the horizontal asymptote is. Now remember, your asymptote, the graph is not defined anywhere along that line. Okay, it's got no value along the asymptote. So the graph will never touch that line. The horizontal asymptote, remember I've shown you before, it's when y is equal to q. And in this case, the value of q is 2. So therefore here, y is equal to 2 is my horizontal asymptote. Okay? Now with an exponential graph, when we look at the y-intercept, if you remember, I've already shown you how you can get it immediately. To get the y-intercept, if you want to do it the long way, you say let x is equal to naught, and you can actually work it out from this equation by doing the whole thing, but we already know, right, from what I've shown you before, we already know the answer is 5 because it's a plus q. But just to go through the motions of showing you how you get it, if you let x equal naught, you get 3 times 2 to the power of naught plus 2. The exponent 2 to the naught is 1. 1 times 3 is just 3, and then 3 plus 2 is 5. So therefore my y-intercept is naught, 5. All right. Now many of you have already done exponential graphs, so you know that there's no point in going on to find the x-intercept, but I'm going to show you anyway. To find the x-intercept of this specific graph, we say, well, generally of all graphs, but the x-intercept for this specific graph, you should know, does not exist, right? But let's go through it. So x-intercept, we let y equal naught, so we get naught is equal to 3 times 2 to the power of x plus 2, right? Okay. The point here is to solve for x, your exponent. We're looking for the x-intercept. If I take my 2 over, I'm going to get minus 2 is equal to 3 times 2 to the x. Divide both sides by 3, you get minus 2 over 3 is equal to 2 to the power of x. Guys, no matter how hard you try here, there's not going to be any solution. Why? You're never going to be able to make these bases the same. You can't use any other method that you know in grade 10 or any other grade to solve this, all right? Because you can't have a negative base equaling a positive base. It's never going to happen. So therefore, there is no solution, so there is no x-intercept. All right, there's no x-intercept here. So we need to plot the graph using the information we've got. We know that we've got an upward facing graph. We know that the horizontal asymptote is y is equal to 2, right? Y is equal to 2 is my horizontal asymptote. So that means at 2 on the y-axis, I'm going to draw the asymptote. Okay? So at y is equal to 2, there we go. We have our horizontal asymptote. I'm just going to extend it a little bit to the left. And let's mark down any of the other key points that we might have for this graph. We know what the shape is, right? And we know that the y-intercept is 5. So we've got an upward facing graph with a y-intercept of 5 on the y-axis there. We put that mark down. We know what the shape is, so therefore we simply join those together, join our points, and that's going to be our exponential graph. So this is y is equal to 3 times 2 to the x plus 2. Guys, you'll notice that when you draw these graphs, it is always a good idea to put down the name of your graph. Also clearly mark your intercepts. Mark your asymptote. Okay, also, which I didn't do here, which I'm very bad at doing, but you need to always put in the labels on your axes. So, you know, the y-axis, the x-axis. Show the arrows showing the direction. Make sure when you draw these graphs, your asymptote and your graph, they should never ever join each other. You don't want them to ever intersect. If they intersect, you will lose marks because that is not correct. Remember, your asymptote and your graph will never meet. All right, so that's just the basic drawing. How do we go about sketching an exponential graph? Well, there we go. That's how we do it. We look for the shape, we find the intercepts, we find the asymptotes, and then we put all of that information together, remembering to label our axes, put down our asymptote on the graph, and also put in all of those key points like your y-intercept. All right, hopefully all of you are with me and all of you knew how to do this one. Okay. Now we're going to move on to the next one, and this is a little bit of graph interpretation, which I know some students sometimes struggle with. So hopefully after doing this one, you'll be able to do our challenge question, all right? Graph interpretation is really just an application of all the knowledge you have about graphs thus far. Okay, so it might look scary when it's put together in one question like this, but we're going to break it down into manageable pieces. Okay, so we've got the graph of f of x is equal to 4 to the power of x. So that's your exponential function, and it's drawn on the graph. You can see they've written there f of x is equal to 4 to the x. They say g of x is equal to minus 4x squared plus q. So that's your parabola. It's a downward facing graph, therefore it has a maximum turning point. The points A, 0 and 1, B, 1 and 4, and C are given. Alright, so I'm going to just put down A is the point 0, 1, right? That's in our little purple dot there. B is the point 1, 4. Okay, now in your graph interpretation questions, obviously all of your questions are going to be based on this figure. Okay, part A says, determine the value of Q. Alright, now if you look at the value of Q, we've got y is equal to, where do we find q? We see that it's part of the parabola equation. That's the one they don't know. They don't know what the value of q is. In other words, where is the graph turning? Because remember from the beginning when I showed you, your turning point on your parabola will always be 0 and q. So really what they're asking us for here is, what is the turning point of this parabola? What is the y-intercept of this parabola? Because remember, your parabolae are always going to turn on the y-intercepts. So we've got y is equal to negative 4x squared plus q. All right, and if you go up to your graph, examine what they've given you. Remember, they've given you some key information here. They've said A is the point 0, 1. So A is the y-intercept of both the exponential function and your parabola. So that's the point 0, 1. Right? So therefore, the value of q being your turning point, being your y-intercept of the parabola, you can read it straight from the graph. The value of q is 1. Okay. So that's quite nice and easy, straight from the graph, reading your answer and giving us the value of q. They then say calculate the length of BC. Okay, now remember we can now change this equation. It's minus 4x squared plus 1. If you're looking for the length of BC, okay, you can see it on your graph. That's the point. B is the point on your exponential function. C is a point on your parabola. Now these 2 points, you can see that they're joined by the same vertical line. That's very important, because if they are along the same vertical line, guys, what does that tell you? Same vertical line. That means the x value along this line is going to stay the same. So therefore the x value anywhere along line BC is going to be 1. How does that help you? Well, we're looking for the length BC. So that's a vertical distance, right? Whenever you're trying to find a vertical distance of a graph, okay, and these points are on the same vertical line, it's always going to be top graph minus bottom graph. So in other words, the y value on the top graph or on the upper graph minus the y value on the bottom graph is going to give you the distance BC. So my y value at point B, the top graph, is 4. I need the y value at point C to determine the distance BC, but we don't have it. So how do we work it out? Well, importantly, they've given us the point X is 1 on this line BC. So if I want to find out what the point C is, all I need to do is substitute that value into my defining equation for the parabola, get the coordinates of point C. Once I've got the vertical point, well, the y coordinate at point C, I can then work out the vertical distance between B and C. Okay, so first thing we do is let's find out what the y value is when x is equal to 1 on the parabola. So at x is equal to 1, I'm going to substitute 1 in place of x, and I'm going to get minus 4 plus 1 is negative 3. All right, so therefore the coordinate now becomes 1 and negative 3. So point C is the point 1 and negative 3. Okay, remember we're looking for the vertical distance BC, therefore we had to first work out the coordinate at point C, the y coordinate. So my distance BC, the distance of BC is going to be the y value on the top, the y value being 4, minus the y value on the bottom graph. So it's going to be 4 minus 3, which is going to give me 7. So BC is 7 units. All right. Okay, that's quite a common question, guys, so make sure you understand how to do that. Remember, any graph, if you're looking for the vertical distance, they lie on the same vertical line. The x values are going to be the same, so therefore you can work out the y coordinates, say top graph minus bottom graph. So in other words, the y coordinate on the top graph minus the y coordinate on the bottom graph, the difference between those two will give you the vertical distance. All right, let's look at part C. They say give the equation of f of x reflected about the x-axis. Now, any point reflected along the x-axis. So, let's just have a look at something on the side here. If I take any points on and reflect it on the x-axis, so let's just say this is the point 2, 3, okay? Reflected exactly the same way at the bottom. Any reflection in your x-axis is going to mean your y values, the sign changes, okay? Because when you reflect along the axis, you're going to go from positive y territory to negative y territory. So therefore, your 2 is going to stay exactly the same because it's still on the same vertical, right? But your y value, you're going to change the sign. So any reflection on the x-axis will mean a different sign for your y value. Okay, so reflection on the x-axis means a change in sign. It's exactly the same the other way around. So if I were to take negative 3 and then reflect it along the x-axis, reflected, that would be positive 3. So it's the same with the graph, right? If you're going to have f of x being reflected about the x-axis, it means all your positive y values are going to become negative and vice versa. All right, so f of x is your graph 4 to the power of x. So simply now, the reflection, did they ask us to call it anything specific? No, they just said give the reflection. So the reflection is going to be, this is on the x-axis, it's going to be y is equal to negative 4 to the power of x. Okay, so the graph is just going to be reflected along the x-axis, so therefore we change from positive y values to negative y values, as you can see there. All right, so y will be negative 4 to the power of x. Okay, let's move on to part D. They then say give the equation of f of x shifted vertically upward by 1 unit. So they've given us a lot of information there. It's moving vertically. Okay, that means straight away in your head, it's affecting the value of q. It's moving which way? It's moving upward, so therefore it's a positive change. So it's moving upward by 1 unit. They say call that h of x. So they're taking the graph of f of x, right, which was 4 to the power of x. We're then moving it upward by 1 unit. So therefore we're adding 1 to every single y value. So my new equation will be h of x is equal to the original function f of x plus 1. Okay. All right, and then I think this is the last one here. 2 more. What is the equation of the asymptote of h of x? So now we've got this new function h of x. We've got h of x is equal to 4 to the x plus 1. The equation of the asymptote, remember, it's always going to be y is equal to q. So y is equal to 1 will be the asymptote of h of x. And then finally, part F, find the range of g of x. So here we're talking about the parabola. Now guys, remember whenever you're talking about the range, you're dealing with the set of y values, okay? When you're looking at your parabola, right, it's either going to be all values above a certain value when you've got a minimum turning point, or it's going to be all the y values below a certain value when you've got a maximum turning point. So your range, if it's not restricted, if your graph is not restricted in any way, it's always going to revolve around the turning point. It's either going to be greater than q or less than q, all right? So if we look at our graph, g of x here, minus 4x squared plus 1, okay, we can see, look at what's happening. The graph turns away at the point 1 on the y-axis. So therefore, you can never have a graph, a point, greater than 1 anywhere here. Doesn't exist for the parabola. The parabola stops at 1. So therefore, your y values are everything less than 1. So your range is going to be y is less than equal to 1. Okay. Or, writing it in interval notation, y is an element from negative infinity, so that means all the values below, starting all the way down. It's all the way from negative infinity up to the point 1, if you want to write this in interval notation. Up to and including, so that should be square brackets. All right, so y is an element from negative infinity to 1. Okay, so that was quite a lot of information to take in there. Maybe a good point for us to stop and check over with you, AB. Are we due for a break?
Yes, we are. Well, Mindsetters, thank you for the questions that you guys are sending. Remember, you have the test to solve questions and the challenge question on facebook.com/learnextra. Also, thank you so much for the tweets that we've been receiving, such as the one from KT the girl, KT_cat saying at LearnExtra, thanks for all you do to help us. This is really working, and keep on doing the good work. We really appreciate such messages. And Mindsetters, stay tuned. We'll see you after the break. Welcome back, Mindsetters. Now, the moment that we've all been waiting for, to hear the winner, our last week's winner for the Grade 10 show, Mathematics. And our winner of this awesome Casio calculator is Emmanuel Emeru. Congratulations to you, Emmanuel Emeru. This awesome calculator, it's coming your way, proudly sponsored by Casio. So Mindsetters, you still have got a chance. Go to facebook.com/learnextra and do the test yourself questions. Get the questions right, and then you stand a chance of winning this awesome Casio calculator. Back to you, Natasha.
Okay, thanks, AB. So, guys, we're carrying on with our section on parabolae and exponential functions, and we're going to now look at the challenge question. And I hope that if you've had any issues with this question or any of the ones that I've done so far, you are letting us know, because we will hopefully have some time at the end of the show to have a look at those questions. Okay, so here, remember, we are given two parabolas, and they're drawn. G of x, which is the name of the function, your positive function here. G of x is equal to ax squared plus p. And h of x is equal to bx squared plus q. All right. The first question says, find the values of a and p. So in other words, find the defining equation of the graph with the minimum turning point here. So that's going to be the 1. Let's just draw it in pink. That's going to be the first one we're looking at. Okay. All right. Now find the values of a and p. Now if you look at what they've given you, they've told you g of x is equal to ax squared plus p. Okay, so g of x is equal to ax squared plus p. And guys, look at your graph. You will see that they have already given you this point. What do we call that point? The y-intercept. So they have given you the y-intercept. And remember, in grade 10, your graphs are always going to turn, your parabolae are always going to turn on the y-intercepts. So if they've given you the y-intercept, it means you already have the value of p. So I can rewrite my equation for g of x as g of x is equal to ax squared, and the value of p is going to be minus 9. And that's really just reading straight from the graph. So looking at your graph, analyzing what they gave you, and writing this down straight from the graph. Okay, A now needs a little bit more work. We go back to the graph. We know what the value of P is. We need to find the value of A, which means in order to find the value of A, I need another point somewhere that lies on this graph. And you're actually lucky here because they've given us 2 points. They've said that's negative 4, 7. And they've told you on the other side, that's 4, 7. Okay. So therefore you have a choice. You can either use the 4 and 7 or the negative 4, 7. We're going to use the negative 4, 7 because it's a point that lies on the parabola. You can use those coordinates and substitute into your equation, because remember, if a point lies on the graph, the coordinates, right, will give you the x and y values on that graph. So if I know x is minus 4, well, at the same time, y will be 7 on this graph of g of x. So therefore, in place of g of x, I can say 7, because that's the y value, is equal to a in place of x. When do we get a value of 7? Well, we get it when x is negative 4. We know that p there was minus 9, so we put that in, and we're simply going to solve for a. So we get 7 is equal to 16a. I'm going to bring the 9 over to the left-hand side. So I get 16 is equal to 16a. So therefore, dividing both sides by 16, I'll get a is equal to 1. Okay? So now, the defining equation for g of x becomes x squared minus 9. All right, so that's part A done and dusted. Let's look at part B. Okay, here they want you to find the defining equation of the other parabola. So they want the value of P and they want the value of Q. And so there we're going to use h of x, which is the name of the other function, the one that's turning around, the one in white now. H of x is equal to bx squared plus q. Again, look at your graph. Do they give you information? Yes, they've given us quite a bit of information. Here we know the graph is turning at the point 23, 0 and 23. So therefore, the value of q, reading it straight from the graph, the value of q is going to be 23. All right. So therefore, we're going to get h of x. Sorry, I don't think it's called h. Maybe it is. Yes, it is. Okay, so h of x is equal to bx squared plus 23, because q was equal to 23, and that's reading straight from the graph. Okay, to find the value of b, we do exactly the same as we did with the other function g of x. If I want the value for b, I can take any point that lies along the graph h of x, substitute it into the equation for h of x. We know what the value of q is. Take either the minus 4, 7 or the 4, 7, substitute it into that equation and solve for a. Alright, so because we used minus 4, 7 before, just to be fair, let's use the 4 and 7 now. So I'm going to substitute the point 4 and 7 into my defining equation and solve for b. Alright, so when y is 7, we know that x is 4. Okay, substitute that into h of x, so we get 7 minus 23 is negative 16. All I did there was take the 23 over. 4 squared is 16. 16 times b is 16b. Therefore, b is equal to negative 1. All right? So my equation now, h of x is equal to negative x squared plus 23. And guys, I always say you need to make sure this makes sense. Does it make sense for the value of b to be negative? Well, of course it does, because that affects the shape. Hey, so if b is less than 0, we're supposed to get a graph that looks like that, a graph with a maximum turning point. So we know that the value of b makes sense for what we've worked out. All right. Okay, hopefully you're all with me now and you all know how to find the equations of the parabola. Remember, just analyze your graph, see what information they've given you, and then use that information to help you determine the unknown values. All right, carrying on with more graph interpretation, this is part C. Find the value of x for which h of x is greater than equal to g of x. So this is your function value, right? Your h of x and your g of x. They're saying, where is the graph of h bigger than, above? Okay, so where is it above or equal to the graph of g of x? The values of x for which this is true. All right. So where is the white graph, which I've left in white, bigger than the graph of the pink graph? Where is it bigger than that one? Okay. So if we look at the graph, we can see that happens in this entire portion. All right, I don't think you can see that color very clearly, but it's in this entire portion here. Okay, it's between there and there. Okay, so we've got to now look at a point. Let's just get a nice pen here. We've got to now look at everything that's happening between those points there. Okay, that's what we're interested in, because if you look at that section, you will see that in that section, every y value on this graph is going to be greater than every y value on that graph at the same point. Okay, so where x is equal to whatever, x is equal to -1, for example, on both graphs, the y value on this graph, the top graph, is going to be greater than the y value on the bottom graph. So that's what you're really doing. You're comparing the y values, and you're saying for what x values this specific pattern happens. When is h greater than g? All right? And we see that that happens all the way from x is equal to -4 all the way to x is equal to 4. So how do we write it down? Okay, and it's very important to get this writing out correct, guys. So here we've got x is an element if we're using interval notation. And they said to you, they asked you, where is it greater than or equal to? Now, equal to, that only happens at 2 points. The two graphs are exactly the same at their points of intersection. So that happens at exactly the points -4 and 4. All right, so they're equal to each other at those points. So what that means is that when we're using interval notation, we need to use, if we're considering equal points, square brackets, because we're including those endpoints. So x is an element from -4 to 4. And anywhere in that interval, it is true that h of x is greater than equal to g of x. So that happens anywhere within that interval. Okay. All right. And then the last one, part D. For what values of x is g of x increasing? So that was part C. Now part D. And you'll notice when we ask you these questions about for what values of x, for what values of x is g of x increasing, when you give your answers, guys, it needs to be in terms of x. So x is an element from one point to another point. It's got to be in that form. Don't now start putting y values when we say for what values of x. Okay, be very careful to answer the question. I just want to show you back on point C before I answer this part here. The other way you could have written this, so we've got x is an element from -4 to 4. You could have also written this as x is less than equal to 4, but greater than equal to -4. But it is very important that you learn interval notation. You will need to know interval notation for your exams. So make sure that you understand how less than equal to, greater than equal to, how that translates into square and round brackets. Okay. All right, so for what values of x is g of x increasing? So when we're looking for an increasing function, what does that mean? That means that as x gets bigger and bigger. So as the x values increase, your y values increase. That's the definition of an increasing function. As x is increasing, your function is increasing. All right? Let's look at the graph of g. Okay, if I look anywhere from the y-intercept there onwards, well, to the left, okay, so backwards. So if I look anywhere beyond that, as the x value, so whatever it was there, and then it moves on here, and it moves, and it moves, and it moves, okay. So as the x values increase, as they move towards the right, you will notice that your graph is decreasing. Your y values are decreasing. That y value is less than that y value. That y value, okay, it keeps decreasing. Okay, so this y value is less than that one is less than that one, as your values for x increase. So anywhere beyond that point, we have a decreasing function. Then if we look from the y-intercept up to this point naught here, same thing. As the values of x get bigger and bigger and bigger and bigger, so as they keep increasing, moving further to the right, the y values keep decreasing. Okay, they keep getting smaller and smaller. Okay, so we know that everything below the point naught, where x is less than naught, all of that's going to be excluded because the graph is decreasing in that entire section. All right? Let's analyze now going forward in the other direction. So if I look for x greater than naught, so now I'm moving this way to the right. As your x values get bigger, so as your x values increase, they move in the positive direction of the positive x-axis, right? As they increase, your y values also increase. So the previous value is less than the following one. So therefore, your y values are increasing as you move to the right of the axis. All right. So therefore, your graph is increasing for all values of x greater than naught. All right. So they say, for what values of x is g of x increasing? Well, that happens whenever x is greater than naught. Guys, they just said increasing, so you're not going to include the naught. So you're not going to put a line like that to say x greater than equal to naught. No, we only want x to be greater than naught because they just asked us, where is the graph increasing? All right. So it's increasing for x greater than naught. Okay, hopefully you're all with me there and you all understand this is a very important section. You need to understand graph interpretation for your exams, for your tests, and so on. So AB, I want to check and see if they are understanding. Do we have some questions that we need to answer?
Actually, on that very same one,
yes.
Krab says, as in the equation of g's to x, a equal to -1.
G of x can't be negative, because you've got a happy face graph. Remember that? It's your shape in your parabola. G of x can't be negative. A has to be greater than naught because that's how it works, really. That's how your functions work. When you're dealing with parabolae, if A is greater than naught, it determines your shape. You're going to get a happy face. You're going to get a minimum turning point. So therefore, it's not possible to consider the answer where you said A is equal to -1. It's not going to make any sense because A has to be positive.
Okay. Another one from Banyana Mohopane. Is the asymptote important?
Yes, it is definitely very, very important, guys. Remember, we dealt with asymptotes last week when we looked at hyperbole, where you had your horizontal and your vertical asymptotes. This week we looked at asymptotes when we dealt with the exponential function. Asymptotes are incredibly important because remember, your graph is undefined. I'm just going to go back to where we had our exponential function, where we drew that. Yeah, there we go. Your graph is undefined anywhere along the line y is equal to 2 in this case. Okay, so if you tried to solve this graph at the point y is equal to 2 at anywhere along that line, you will see that your graph actually does not exist. Guys, you can try it out. I mean, if you put 2 in here, you're going to get 2 is equal to 3 times 2 to the x plus 2. Okay, so say you were trying to show that this existed somewhere along the line y is equal to 2. So you're saying this graph, 3 times 2 to the x plus 2, has a y value of 2. Look what would happen. You take the 2 over to the left-hand side. 2 minus 2 is 0. You get 0 is equal to 3 times 2 to the x. There's absolutely nothing you can do here. Everything cancels. You just get what? Divide through by 0. You get 0 is equal to 2 to the power of x. It's not possible to solve this because there's no way that you can make the bases the same or that you can do anything to get 2 to any power equal to 0. It's never going to work. For any x value, you're never going to get that to work out. So therefore, if you believe or if you're questioning is something right, is something wrong, just take a value, test it out and see if it makes sense. And in this case, you can see that if we were to assume that the asymptote did exist, it did exist for a value of x on your exponential graph, just by testing, you can see everything just disappears. You can't do anything along that line.
All right, because of time, I'm just going to give you one last more question. So, Piso, how do the brackets differ when writing the range and domains of graphs?
All right. Okay, so I'm going to go through it very quickly because, as AB said, we don't have much time. But I just want to remind you guys that when you're dealing with your brackets, your interval notation, okay, so this is interval notation, right? In order to show that a value is included, okay, so if we want to show an included value, so say we wanted to say x is greater than or equal to 0. Let's just say that was your range for some graph. In order to show in interval notation that the x is greater than or equal to 0, that the 0 is included, you would say x is an element and you use square brackets. Square brackets denote included. X is an element from 0 up to, if it's just greater than 0, it's going on infinitely. So from 0 to infinity, you can never include infinity because you don't know what that end value is. Hey, so therefore we use round brackets to show excluding and then square brackets to show including. All right.
I hope that helps the mindset.
I think it will. I think it will. Thank you guys for all your questions, and I hope you've enjoyed the show and you've learned a lot. Until next week. Thanks.
Thank you so much, Natasha. And mindsetters, remember, you can still go to moremaths.org and then your code is 2FB5. But for today, that's where we end it. And we love you so much. Peace.